All right. Hello. Welcome. Good afternoon, Chicago. Yay. I'm super thrilled to be here, not only because it's my first overseas conference, but because I got here at all. Because my flight was canceled 3 times, and I just talked to Jim Evans, and it was probably his fault. Because he said whenever he flies, everybody else flying is affected by some troubles. All right, so this is the topic for today, identifying code smells. And let's get me out of the way quickly, because I'm not the important part here. My name is Benjamin. I'm a test automation engineer in Germany, in Düsseldorf, Germany, at trivago. For those of you who don't know trivago, it's a hotel meta search that compares hotel prices for you. I just half an hour before this talk, I had to correct this slide because it said I'm 22 years in IT. It's actually 23 years now. And the last 8 years I spent in testing. Before that, I was a full-time developer. And that's probably also where this topic and this talk came from, because one part of my mission is to introduce or reintroduce clean code principles back into test code, because I see that there is some lack. A little disclaimer, this is only about the identification of code smells, not how to fix the issues that might be related to them. I will show lots of code, a whole bunch of code, and it's all going to be in Java. I'm sorry, but I see one fan of Java here. 2, 3, cool. Because Java is still the language I hate the least. Yeah, my favorite language doesn't exist anymore. It was ActionScript 3, but I don't know how many remember this. This next slide is entirely for me. If you don't find it funny, it's okay. I really like it. If you don't get this reference, you're either too young or too old. And I also know this is the wrong city to show this in. For those who don't know, this is from Friends. If you want to look it up, the original, it was not Smelly Code, it was Smelly Cat. But let's start now. Let's start with the term code smells. It actually came from this book, Refactoring by Martin Fowler. He wrote this with Kent Beck. And in this book, they define code smells like this. A code smell is a surface indication that usually corresponds to a deeper problem in the system. And that is the important part right up front, because it does not mean you have a problem in your code. It can mean you have a problem in your code. The things that could look like code smells can be wanted in your code, depending on the circumstances. Why should you care about code smells? Well, first of all, it doesn't matter if you are anywhere on the spectrum from tester to developer, developing tester, testing developer, it doesn't matter. It simplifies communication. If you can point out code smells and name them, it's much easier to talk about them than to just say, I think there's something fishy about this. Also, it leads to better code. If you can talk about those code smells and then introduce principles, clean code principles, and design patterns, you can make this code significantly better. And also, let's not forget this, testable code is maintainable code. So if the code is not testable, you should usually have some code smells there that you should tackle. There was a problem with this book, and this was that those smells were not really categorized. They were just scattered throughout the book. So those 2 people from the Helsinki University of Technology devised a taxonomy of code smells that I will use during the rest of this talk. This is the classification they came up with. And I don't want to scare you, but we will go through all of them. all of those smells that are listed there in the remaining 20 minutes. Let's see, 22, because there might be some room needed for Q&A. Let's see. So let's start with the first category, bloaters. And the bloaters category is something that is too large to handle. And as you will see, this does not mean that the code is too large, but that what the code does is out of scope. You see it here. The first smell in this bloaters category is long method. That is a method that does too much. And don't worry, you don't have to read through all the code all the time. I will highlight the parts that I think are important. So we have a web shop class here, and this class has a method called saveCustomer that you pass a customer to. The implementation details are not that interesting. And you see in the first line of this method, it says customers add customer, so this is where the customer is actually saved. But then you will notice down here that it returns a string saying, we have a new customer called, and the customer name. This is out of scope, because if you look at the name of the method, saveCustomer, you would not expect that it returns a string. And if you don't really document what you're doing here, that can be really, really confusing. The same principle of the long method can also apply to classes. In this case, it's called a large class. I took a shopping cart example here and 3 methods that belong to a shopping cart: add product, remove product, checkout. But here, the last 2 lines are 2 additional methods: enter voucher code and contact support, which is not necessarily related to the shopping cart. So in this case, the class is doing too much. What's down here is out of scope. See, we already went through 2 code smells, only 19 remaining, I think.
1 per minute.
1 per minute, could work. Primitive obsession, that is actually a little bit tricky to explain, because in some programming languages you have primitive data types, like here the int data type, that can be used for a zip code. And for where I come from, for German zip codes, that would be perfectly fine, because I think we don't have zip codes that start with a 0. But for other countries where there are letters in the zip code, that is not enough. Also, you can store any int in there. You can store -1, you can do 0, you can do -100, whatever you want. So there is no validation there. All of this just screams custom zip code class that includes all of this. All right, next one, long parameter list. That is something I am guilty of myself when I write code. And what I mean by this is you have too many method parameters. So here we have some class with some method called calculate results. It doesn't matter what it calculates, but it has 5 parameters. It has an int base value, it has 2 booleans, it has another int, and it has an integer, which can even be null. So when you call this method, you will see something like this. Calculate results, 13, false, true, -1, null. Nobody will know what this is, what this means. If you have a good IDE, you might get some variable hints, but if you look at this in a text editor, you have no idea what this does. Also, because we're at a test conference, even though Selenium is not a test tool, this is a nightmare to unit test, because you have so many branches, especially when you have method parameters that are booleans. that always indicates that you could separate methods. And testing all the possible combinations is just impossible. Data clumps. That is, I think, the last one in the bloaters category. That is grouping unrelated data. And that doesn't mean completely unrelated, but that's why it's called a code smell, because you smell there could be something there. You have a customer with last name, first name, middle name, salutation, but then you also have an address in here, which does not really, in all cases, belong to the customer, because a customer could also have multiple addresses. Some customers could share an address, of course. And you have some more information here. Is employed, is homeowner. That can all be somewhere else. But let me repeat, it doesn't have to be. It can make sense in your code. One category down, 4 to go. OOP abusers. That is related to object-oriented programming languages. And that is when you write code that does not use the OOP principles that this language offers you. Like here, switch statements. Branching out too much. This is a very, very stupid method. It's, yeah, I know, I wrote it myself. It gives you the number of wheels for a vehicle, and you pass this vehicle by string. That is, even by my standards, that is stupid. And the implementation is down here. So you have a switch statement that takes this vehicle string and then returns for car, it returns a 4, for boat it returns a 0, for bike a 2, for bicycle also a 2, because you never know how you spell it, and otherwise it returns unknown. That is just not using any of the object-oriented programming principles that you could use here, like having a base class for a vehicle or having interfaces that give you the number of wheels. But I won't go into detail here. Temporary field. This can be hard to spot. That's why I try to keep this example as simple as possible. I'm using a rectangle class here. And this rectangle has a method called getAreaSize. And as probably all of you know, it's by just multiplying one side of the rectangle by the other side that gives you the area. But where do you get those sides? And in here you have two variables called side A and side B. But in order to fill them with values, you have to call those two methods, set side A and set side B. That means if you create a new rectangle and you call the getAreaSize, you won't get anything. You will get a 0 because you have to set those two sides first. Again, this is misusing the object-oriented programming language, because you could just pass the two sides in a constructor of the rectangle and that's it. That's why it's called temporary field, because it's fields that are only used once. Then we have a smell that is hard to pronounce. It's called refused bequest or bequest. I have no idea where you put the emphasis. That means passing unneeded behavior to classes. We have our good friend, the animal class, that is in every programming beginner's book. And it has an interface animal with a method speak, which is perfectly fine if you want to create a dog, because you let the dog implement the interface animal, and then, oops, I'm sorry. I'll do it again. There's the rectangle again for those who missed it. There's the dog again. It implements the animal interface, and you override the method speak, and in this case I just return wolf. But what happens if you have a fish? Then you implement the animal class because an animal is a fish, but you override the speak method and you have nothing in there. That makes no sense. This code smell points to a problem because you're passing unneeded behavior to classes. It would be much better to have a speakable interface or something like this, or a base class that can speak. Now, this one I hate. I've seen that especially in PHP a lot. It's called different interfaces. That is when similar functions are named differently. Like in this circle class, we have the area size method again, and this area size method is called getAreaSize. But for the rectangle, the method that does a very similar thing, give you the size of the area, is called getSurfaceSize. This is not really a problem that will bother you that much, but it can lead to a deeper problem. If your naming is off, it can feel weird for users. And especially for the case of PHP, if you have used one method a lot of times before and you want to use a similar method on another object and it's slightly off, I hate that. Next category, we're right in the middle category. Change preventers. That is something that hinders further development. First one is called divergent change. And divergent change is a change that has to be made across methods. We have the animal, again, in this case an animal information class, and a method that gets the Latin name. Again, we pass here an animal by string, which is stupid, and then it gives you the Latin name. And there's another method that's called getNumberOfLegs. You pass an animal and you get the number of legs. What happens if you add another animal? You have to implement this in two places because you can get the Latin name for a fly, but if you forget to implement the same in the other method, you get no number of legs. For classes, this has probably one of my favorite names for code smells. It's called shotgun surgery, because you take out your shotgun and you shoot your change across the whole application, because this is something that you have to change across classes or implement across classes. I changed the code from before. Now we have a classification class with the getLatinName method. And we have a class that's called bodyparts with the getNumberOfLegs method. Exactly the same thing. If you want to implement a fly, you have to do it across classes. Because again, if you forget to implement it in the bodyparts class, you will be in trouble. And this is not a made-up example. I've seen code like this actually a lot. Now then, this next one is probably the hardest one to explain, but let's see if I succeed. It's called parallel hierarchy, and that is implementing parallel interfaces. The code doesn't look that complicated, but the concept is a little bit weird to explain. We have a bird, and we have another class, sparrow, that extends the bird class. And we have an egg. And we have a sparrow egg that that inherits from the egg. Now that means if you call the lay egg method from the sparrow and it returns you a sparrow egg, you have an egg, you have a bird, and you have two interfaces, a sparrow and a sparrow egg, that are connected but are on different branches of the hierarchy. So this can be super confusing if you have that, especially if this hierarchy goes on forever. Hope that was kind of clear. Yeah, here's the lay egg method that returns a sparrow egg. Again, if you add more birds and more eggs, you have also branching out of the interfaces on two parallel branches. Wow, next category already. We're good in time. Dispensables, unnecessary things that can be removed. Probably my favorite category because I love deleting code much more than writing code. And the first one is called lazy class. And this is something that is highly dependent on your application and the design patterns you use. There's a web shop checkout that has one method that is called checkout. So it's a class with a single method. Depending on the pattern that you use, if you use something like the memento pattern where you implement different commands that you can undo later, that makes perfect sense to have one method per class. But in most applications, a class with one method is a code smell. Yeah, there it is, the only method. Data class. A data class is a class that holds its own data, but not its own logic. We have our friend the rectangle again, this time implemented correctly with a constructor, side A and side B. I'm using Java's record here to do it, so I don't have to write all this boilerplate code. But in the main method of the application, where you create this rectangle, you also do this. You calculate the rectangle area by using the side A of the rectangle, the side B of the rectangle, but outside of the rectangle class itself. You're using its data, but you would probably expect the rectangle can return its own size. Now this one is easy. That's duplicate code. That is the same code multiple times. It doesn't really matter what this class does. Add customer, remove customer are the two methods, but I wanted to log the customers that exist after this operation. So I just implemented some code here to dump the customers on the terminal. And for the remove customer, I have exactly the same code to do it. But whenever I want to switch out this line or change it, that is again shotgun surgery or divergent change. But in this case, it would be much better to just have a lock method. So duplicate code is a sign that you should extract that out. This one you probably all know. It's dead code. It's code that can never be reached. And if you use a fairly modern IDE, you will not run into this problem. But depending on what you use to look at code, that can happen. Here I have a method called getPy that just returns the number pi that I can use in mathematical operations. But later I discovered, oh, Java already has a constant for pi built in. That's great. So I used this. But then I forgot to remove the old method. That is then dead code. So if you don't use some code, just delete it. That's what version control is for. You don't need to store copies of the former state. Also, if you noticed, I hit actually dead code within dead code, because this, this line can never be reached, because after the return, the method is done. So, hee hee. That's another great name for code smell, called speculative generality. That sounds way more fancy than it is. In my example here, there's a printer interface with two methods, print and turn on or off. And up here, I have a laser printer that implements this interface and then, of course, overrides those two methods. The problem here is, if that is the only printer I have, you wouldn't even need this interface. Speculative generality means that you are trying to prematurely future-proof your application for the case when you sometimes might have a new printer. And that is too early. You should only do it when you get a new printer and then change your application. Last category, couplers. Too much or too little coupling. And this one, they're all related, by the way. It's really hard sometimes to find the right name for a smell because they're so closely together. This is called feature N.V. It's a class that implements features of another one. We had that before with the data class that holds the data but not its logic. This is like the other way around. There's an address with street, city, and country. And we have a user. And the user has the method getAddressString. So it takes the address and extracts all the information from it and creates a string for the address that you would normally expect to be in the address class. For this, it can make a lot of sense, though, to have this in the user, depending on your use case, but you should look at cases like this more closely because there could be something deeper hidden inside it. Now comes my favorite code smell because of the name. It's called inappropriate intimacy. I love that name. And it just means this. You have a book class, and the book has an author. And of course, you have the author class, because the book needs an author, but the author also has a book. So you have this circular reference. You have one class knowing the other, and the other class knowing the one, which can be wanted if you use any data abstraction framework, ORM framework. That can happen, but usually that's not something you should have. You should avoid those circular references. Now, this next one is probably the one I see the most in the wild. It's called message chains. It's really hard to say, message chains. It's objects that return other objects that return other objects, and so on. It doesn't really matter what this code here is doing. It's a storehouse code. And in this case, I want to get the description of the first product on the first shelf. So I do shelves.getZero.products.getZero.description. It not only looks ugly, but it has a lot of problems if somewhere along the line one of those components is null. Then you get the dreaded null pointer exception, or NPE in Java. That is the most thrown exception in the universe, probably. And if I'm not mistaken, this is the last code smell already. It's called middleman. And we have seen something along this line before. It's a class accessing another one on its behalf. We have the address again. with a street in the city. And in the customer, we have a method getCity that takes the city from the address and returns it, and getStreet that gets the street from the address and returns it, which is totally unnecessary. You have one layer of abstraction here that is doing nothing, because you could just do customer, address, city, instead of going through all this code. And there you have it. We went through all the code smells. You don't have to remember all that. I also put all this code in my GitHub repository under Bischoff dev, that's me, /codesmells. And in the few remaining minutes, I would like to quickly talk about when to tackle those code smells. No? Never? Well, I disagree. There is something that's called the broken window syndrome. That is always compared to a house with a broken window. If this is not fixed in time, there will be people that say, oh, there's a broken window, let's break another one. Oh, let's leave some garbage in the hallways. That's not good. So, I just heard that's his project, I'm sorry. So you should think of long-term effects of unfixed code, and you should fix those things as early as possible. Like I said, code smells don't mean you have a problem in your code. It can mean you have a problem. So it's good to talk about that as early as possible. Also, the premature future-proofing I mentioned, that's commonly called YAGNI, for you ain't gonna need it. It's, it's wasting time with future requirements. All this time is unnecessary if you try to future-proof your application now, and you have to test it now without having a real use case for it in production. So you should spend your time more wisely and wait with those things until you need them. Also, there's the campground rule that says leave the campground cleaner than you found it. Whenever you find things in code that you're reviewing, it doesn't hurt to point it out. I mean, you don't have to say that is crap. You can be polite, but it doesn't hurt to talk about that, because later never comes. Oftentimes I see pull requests saying, it works, I will make it pretty later. That will never happen. So do it now. And code reviews are a great place to start, to point out smells before it's too late. And don't be afraid to point those things out, because it will help everyone. Always remember the song. And with this, thanks a lot for having me. And if you have any questions, thank you. There is one question.
Provide us something to read, except that refactoring.
Hang on just a second. We're recording, so.
Okay. Thank you very much. Sure. Could you please recommend something to read, except that first refactoring book, which we probably everybody read, right?
I actually learned a lot about, I have to look up the specific titles about, from books about extreme programming. I have read books on design patterns. Apart from the original design patterns book, there's also one that's called Head First Design Patterns. That's also really, really good. There are also online resources for the refactoring book, and also I will have to send this to you later, because there is an online resource where you can actually see all the code smells and what you should do as a next step. That's really handy. I will find it.
I know there's one book called Effective Java that I've gotten a lot of work
Yes.
value out of. Joshua Block. I don't know if it's updated to the most recent, but it is really good. Yeah, it's a
Yes, that is also a great
Yeah.
book.
Hi. Is there any IDE plugin that you would recommend that helps identify some of these code smells?
You can, in terms of IDE plugins, I'm not so sure. I mean, you can use technologies like SonarQube. You can use checkstyle to enforce a certain style of code, which makes it easier to spot those code smells. So if you have a lot of developers working in their own way to write code, it can be hard to spot. But if you enforce a certain style, that helps already. I personally, I'm not associated with JetBrains, but I use IntelliJ, which does a superb job pointing out some of those smells, giving type hints, giving parameter names in methods. So that helps already.
And they're a sponsor.
That is also true, and they're here.
Oh, yeah.
So when you find one of these code smells, what's the best way to bring them to the rest of the team? How do you approach them using this information, these categories?
Yeah, we have a very good pull request review culture, I would say, by now. So we usually point those things out in the code reviews. Also, sometimes if you do pairing on code, you can avoid those directly when writing code. If you do methodologies like test-driven development, this is also a great way to not run into those code smells in the first place. But usually it's respectful communication that you need to talk about those things. So if you cannot do that between testers, developers, reviewers, you have a deeper problem in your organization than code smells.
All right, well, I think we're about out of time. Thank you very much, Ben.
Thank you.